Welcome back to the channel. In this video I am putting up the solutions to 10 questions which appeared in a separate video. The link to that video you can find below. In actual fact, I'll just put up the solution to the first two questions here, and then in separate videos I'll put up the solutions to the other questions. This is so that the videos are not too long. So let's begin. So question 1, what is the total mass of gas produced when 100 grams of cyclohexene are fully combusted with excess oxygen? Now, to answer these questions, first of all we need to look at the reactant that we have. So in this case it's cyclohexene, and we need to write down the molecular formula. We see the structure of cyclohexene there. It's a ring with one double bond. So the molecular formula will in fact be C6H10. Obviously we've got 6 carbon atoms because we've got 6 vertices in the ring. And then on 4 of the vertices we have CH2, 2 hydrogen atoms. And on the 2 vertices where the double bond is, we just have CH. So 4 lots of H2, that's 8 H, and 2 lots of H, that's 2 more, so that's 10 altogether. So C6H10. The next thing we need to do is to construct an equation for the combustion. Now, when we combust any hydrocarbon, as long as we've got sufficient oxygen, and it says we've got excess oxygen here, then we get carbon dioxide and steam, or steam, obviously water, H2O. So now we need to balance the equation. So on the left hand side here we have 6 carbon atoms. So we need to have 6 carbon atoms on the right hand side, and to achieve that we need to put a 6 in front of the CO2. So we've now got 6 carbon atoms on the right. Now let's look at the hydrogen. On the left we've got 10 hydrogen atoms, so we also need 10 on the right, and to achieve that we need 5 in front of the H2O, 5 times 2 being 10 for the hydrogen. Now let's look at the oxygen. On the right hand side we've got 12 from the 6 CO2, 6 times 2 being 12, and a further 5 from the 5 H2O. 12 plus 5 is 17, so we need 17 oxygen atoms on the left, and since we've got O2 there we need to put 8.5, that being half 17. So now we've got 17 oxygen atoms on the left and also on the right. So now the equation is balanced. So what does this tell us? Well, it tells us that the combustion of 1 mole of C6H10, cyclohexene, gives us 6 moles of CO2 and 5 moles of H2O. So we know how many moles of gas we get when we do the combustion. We've now got to work out what mass of gas that will be. So to do that, we need to find, first of all, the molar mass of CO2. And so let's do that. So that will be 12, 12 being the atomic mass of carbon. And then we've got plus 2 times 16, 16 being the atomic mass of oxygen, and it's 2 times 16 because we've got CO2. So if we add those figures together, we've got 12 plus 32, 44. So 44 grams is the molar mass of CO2. But in the equation there, we've got 6 moles of CO2, so we need to multiply the 44 by 6, and when we do that, we get 264 grams. So that's the mass of CO2 we get when we combust 1 mole of cyclohexene. Now we need to do the same for the water. So working out the molar mass, first of all we've got 2 times 1, 1 being the atomic mass of hydrogen, and we've got 2 hydrogen atoms there, and now add on 16, that being the atomic mass, sorry, it should have been the atomic mass of hydrogen, so we've got the 16, the atomic mass of oxygen. Adding those figures together, we get 18 grams. And we've got 5 moles of steam, or H2O, so we need 5 times 18, 90 grams. So the total mass of gas we get is 264 grams of CO2 and 90 grams of H2O, steam. Adding them together, we get 354 grams. So that's the total mass of gas produced when we combust 1 mole of cyclohexene. But in the question we haven't got 1 mole, we've got 100 grams. So now we need to deal with that. So let's find the molar mass of cyclohexene. So we've got C6H10, so 6 times 12, 12 the atomic mass of carbon, and 10 times 1 the atomic mass of hydrogen. Adding those figures together, we get 82 grams. So this means that 82 grams of cyclohexene, when combusted, produce 354 grams of gas. So we've got 100 grams, so to work out what we get there, we just do 100 divided by 82 and multiply by 354, and that gives us 431.7. And we can see the closest answer is C. So the reason it's not we're a little bit over the 431 is that we took integer values for the atomic masses of carbon and hydrogen, when in fact they're not integers, on account of there being isotopes in the elements. So let's go on. So now we've got question 2. What is the percentage mass lost when aluminium carbonate is heated and fully thermally decomposed? And then we've got 4 possible answers. Now, when we thermally decompose carbonates, we get the oxide and carbon dioxide. So first of all, let's get the correct molecular formula for aluminium carbonate. Aluminium forms 3 plus ions, aluminium being in group 3, and the carbonate ion is CO3 minus. Now, aluminium carbonate has no overall charge, so to achieve that, we need to have 2 lots of Al3 plus and 3 lots of the CO3 2 minus, so the 6 plus and the 6 minus balance out. Therefore, the formula for aluminium carbonate is Al2CO3 3. Now, when we do the thermal combustion, as mentioned, we get the oxide and carbon dioxide. So, as with question 1, we now need to balance the equation. Well, the aluminium atoms are balanced since we've got 2 on each side. The carbon, however, we've got 3 carbon atoms on the left. On the right, we've only got 1 in the CO2, so we need to put a 3 in front of the CO2 so that we've got 3 carbons on the right as well. Now looking at the oxygen, on the left we've got 3 times 3 is 9 oxygen atoms. On the right hand side we've got 3 in the Al2O3 and a further 6 there, 3 times 2 in the CO2. 3 plus 6 is 9. So in fact the oxygen is now balanced. So now, as before, we need to work out the molar mass of the reactant, which in this case is aluminium carbonate. And to do that, it will be 2 times 27. 27 is the atomic mass of aluminium. 3 times 12. 12 the atomic mass of carbon. And 9 times 16. 16 the atomic mass of oxygen. Adding all those figures together, we get 234 grams. So if we combust 1 mole of Al2CO33 aluminium carbonate, we get 234 grams of, well, no, that's 234 grams that we're combusting. What do we get? Well, it's the molar mass of Al2O3. So let's calculate that quickly. 2 times 27, 27 the atomic mass of aluminium. 3 times 16, 16 the atomic mass of oxygen. Adding the figures together, so we got 102 grams there for the molar mass of Al2O3. So 1 mole, 234 grams of aluminium carbonate gives us 1 mole, 102 grams of aluminium oxide. What mass have we lost? Well, it's clearly 234 minus 102, which is 132 grams. So expressing that as a percentage, it will be 132 over 234, what the mass we started with, times 100%, and that's 56.4% approximately. Clearly the answer is D. So those are solutions to the first 2 questions. I'll put up the solutions to the others in separate videos. So thank you again for watching the video. I hope that it has been helpful for you, and we'll see you the next time.